Okay, so now if we're looking at converting between rectangular coordinates and polar coordinates. So we learned this back in the day, this relationship here, cosine of theta equals x over r and sine of theta equals y over r. And these were in terms of the rectangular system. So if we were changing this and writing it as a polar coordinate, and remember polar coordinates, so there's rectangular, polar coordinates use r and theta. Well, if I took this cosine and I solved it for x, so if I took cosine theta equals x over r, multiplied both sides by r, I end up getting r cosine theta equals x. So you can replace the x with r cosine theta. Same thing here, multiply both sides by r. You get that r sine theta is the same thing as the rectangular coordinate y. Okay, so this relationship will come in really handy in the future. Okay, example 3. So find the rectangular coordinates of the points with the following polar coordinates. So here's our polar coordinates, 5 pi over 4. Let's start with that one. All right, so if we're letting this be, there's our r, there's our theta, and we need to convert this to an xy value. So rectangular means xy, polar means r theta. Okay, so again, we learned that relationship that x equals r cosine theta. So that means that the x value is going to equal 5 times the cosine of pi over 4. So I get 5 times root 2 over 2, which is 5 root 2 over 2. So I've got that value. So my x value is 5 root 2 over 2. And then my y value is r times the sine of theta. So 5 times the sine of pi over 4, which gives me 5 times root 2 over 2, so also 5 root 2 over 2. Okay, so if I was doing this other one, same kind of deal. If I was to, there's your r, there's your theta. Okay, all right, so x equals r cosine theta. So that's going to equal negative 2 times the cosine of 5 pi over 6. So negative 2 times, so the cosine of 5 pi over 6 is going to be the negative of pi over 6. So that's root 3 over 2. So that ends up giving me root 3. And then for my y value, so that's r times the sine of theta. So that's going to be negative 2 times the sine of 5 pi over 6. So 5 pi over 6 is in the second quadrant. So sine is going to be positive there. Reference angle is pi over 6, and the sine of pi over 6 is 1/2. So we end up getting negative 1. So if I were to graph these, just to give you guys some practice of graphing these, this would give me, so if I was looking at this first one here, 5 pi over 4, so you draw your pi over 4 angle, so pi over 4 is going to be about right here. And then if we're talking about 5, so that's 1 circle, 2, 3, 4, 5. So that's going to put that point right here. If we're talking about negative 2, 5 pi over 6, all right, so first let's draw 5 pi over 6. So there's 5 pi over 6, but I'm doing a negative radius, so that means I'm going in the number line in a negative direction, so that's going to put our point right here. Okay, so this point's right here, and then this guy's right here. All right, example 4. Plot the point negative 5, 0 on the rectangular coordinate system. So negative 5, so that means my x value is negative 5 and my y value is 0. So I'm right here. Okay, now it says, with the polar axes superimposed on the system, find the value of the angle, and the number of units on the terminal side of the angle can be determined. This point we can express in terms of polar coordinate points of r theta. So our radius is 1, 2, 3, 4, 5. And the angle, if we're using a positive radius, we've got to start from the x-axis. So our angle is pi. So again, if we were asked to plot the point 0, negative 4 on the rectangular coordinate system, so that's an x value of 0, y value of negative 4, so that puts me down here. And then if we needed to write it in terms of a coordinate, this would be 1, 2, 3, 4, so our radius is 4, and the angle that's going to give us that is going to be 3 pi over 2. All right, let's keep on kind of going with this. So if we were asked to plot the point negative 3, 3 on the following rectangular system, let's see, so negative 3 and then 3, so we're right here. So we're in quadrant 2. From the pole, draw in the terminal side of the angle theta. The distance from the pole to the point is the radius of the circle. We'll draw our pole right there. So there's our radius. The relationship between r, x, and y, so we know that relationship is x squared plus y squared equals r squared. So we can use that to find r. So again, here's our x, here's our y. So we've got negative 3 squared plus 3 squared equals r squared. So we get 9 plus 9 equals r squared. So 18 equals r squared, which means square root of 18 is r. And then again, to figure out that relationship between x and y and tangent, so tangent, we remember, is tangent is theta, or sorry, I don't know what I'm doing. So tangent of theta is equal to y over x. I'm going to write that one more time. Tangent of theta equals y over x. So we can use that relationship to find our theta. So tangent of theta equals our x is negative 3. Oops, that needs to go on the bottom. And then our y is positive 3. So I get tangent of negative 1. When I do the tan inverse of both sides, we end up getting 3 pi over 4, which you can think about. If you have your little chart, we know that tangent equals positive 1 at pi over 4. I'm in the second quadrant. So when I do if you do the tan inverse on a calculator, you'd get negative pi over 4. So again, to figure out what that equivalent angle is in the second quadrant, it's going to be taking pi minus pi over 4, which gives us that 3 pi over 4. And then if we had to verify this polar coordinate by plotting it on the graph and confirming it's at the same location, if you end up, so you would plot your radius, which is 3 root 2. Once we reduce that r, so the square root of 18 is the same thing as the square root of 9 times the square root of 2, which gives us 3 root 2. Oops. And then your r value, so your theta value is 3 pi over 4. And we end up seeing that 3 root 2 is about this length. And then again, 3 pi over 4 would get us to right there. So that works out.